What are the steps involved in creating a new microservice for your application? Well, first of all, you'll typically want to create a new source control repository for your microservice code. While it is technically possible to keep the code for all your microservices in a single repository, that can become very unwieldy if you have many microservices, and it also greatly increases the risk of introducing tight coupling between your microservices, which is something you really want to avoid. You should also set up a continuous integration build, which will build a new version of your microservice every time someone commits code into the source control repository. And this build should also run any automated tests you've created, and the build should fail if those tests don't pass. In fact, tests are a super important part of building microservices, so let's talk about them next. Automated tests are a critical part of being successful with microservices. We're not actually going to go into them in great depth on this course, because other courses on the microservices learning path here on Pluralsight are going to cover them in a lot more detail. But I do want to quickly mention 3 very important types of test that you should be aware of and be creating. The first is unit tests. These operate at the code level, and they're typically very fast to run. If you're following a test-driven development or TDD process, then you'll already be creating these. And you typically want lots of unit tests and for them to have very good code coverage, especially any business-specific rules or logic. The second is service-level tests, or sometimes called integration tests. We want to be able to test an individual microservice in isolation from all the others. And these tests often require us to deploy an instance of the microservice to a host and configure it to talk to stubbed out or mocked versions of its collaborators, although it will talk to a real version of whatever database it's using to store its data. Then you run a series of tests that call its public API and verify that you're getting the expected responses from those endpoints. And these sorts of tests are harder to write than unit tests, but they are tremendously valuable. So it's worth investing the time to create a framework that allows you to create these service-level integration tests for each of your microservices. And these tests too ought to be run as part of an automated build process. Finally, there are end-to-end level tests. And these are where you test all of your microservices running together in a production-like environment. And you automate some key journeys through your application from the user interface that exercise as many parts of the system working together as possible. And these types of tests can be much more challenging to write and maintain, as they tend to be fragile and brittle and prone to failure due to transient problems. So try to verify as much functionality as possible with the other types of test, but end-to-end tests are still very valuable, even if you're just using them as what's called a smoke test that helps you determine that your system isn't completely broken, but is still able to provide some of the key bits of functionality end-to-end. Rather than starting from a blank sheet of paper for every microservice, it's a great idea to have some kind of standard template. This could be an actual template that you maintain in its own code repository that's used as the starting point for every new microservice you create. Or it could be that you nominate a particular microservice as an exemplar. In other words, it demonstrates a pattern that other microservices should follow. And the reason for doing this is that there are many things that it's a good idea to standardize across all your microservices. Let me give you a few examples. Logging. All of your microservices should be emitting logs in the same format and sending those logs to a centralized location. Health checks. It's a great idea for every microservice to have a way of reporting its own health. Is it up and running yet? And can it talk to its downstream dependencies such as databases or maybe other microservices? Configuration. It's a good idea for all of your microservices to take the same approach to accessing secrets and configuration. Authentication. You might have some standard middleware that sets up the necessary authentication pipeline for your technology of choice, such as ASP.NET or Node.js. And by having a standard approach to that, You reduce the risk of developers accidentally misconfiguring authentication and leaving a microservice unsecured. Build scripts. It's a good idea for there to be a standard way for developers to build the code. In the example we've been looking at, it's using containers, so each microservice needs to have a Docker file that produces the container image. And of course, there may be some additional things that you want every microservice in your application to have by default, so include those in your template or exemplar as well. Now, by providing all of these things out of the box, you're going to greatly reduce the time needed to get a new microservice up and running, and you also ensure consistency across your product. Now, of course, this type of standardization might constrain some of the freedom that we discussed earlier that microservices give you to adopt new technologies. For example, you might decide that you're going to standardize on using one particular programming language across all your microservices. And that makes quite a bit of sense, as it allows developers to more easily move between working on different microservices. But do try not to be so rigid with your standardization that you prevent teams from being able to choose the best tools for the job. The end goal of this is to provide a friction-free development environment. In other words, we want developers on our microservices application to be as productive as possible, and to be able to spend their time focusing on implementing the business requirements of the microservice rather than all the plumbing and infrastructure surrounding microservices. It should be possible for each developer to work on a microservice in isolation, running service-level integration tests against it to check that it still honours its contracts, but it should also be possible for each developer to test their work in the context of a full system. Depending on the size of your microservices application, it might be possible for developers to run everything locally on their development machine, just like we saw with the eShop on Container application and Docker Compose. Or you might decide to take a different approach, where your developers connect to shared services running in the cloud. Whichever option you choose, try to ensure that the process is as streamlined and automated as possible. In this module, we looked at a few different options for how microservices can be hosted, and we saw how containers can offer us a particularly good local development experience. We discussed the fact that each microservice should have its own source control repository and continuous integration build configured. Automated tests are vitally important for microservices, and we said that each microservice should have its own unit tests as well as service-level integration tests. And there's also the need for end-to-end tests that verify that the microservices integrate with one another successfully. We saw that there are several things that are worth standardizing across all your microservices, such as the approach to logging or authentication. And a great way to achieve that is by using service templates, which serve as a starting point for creating a new microservice. In our next module, we'll explore the options for how microservices can communicate with one another.